So now we're going to do question 4. We are given the sketches below and the equations of the graph of f and the graph of g, and we are given point A and we're not given point B, and we are told that both graphs intersect at B and D, and we're also given the coordinate of E, right? So now let's look at the questions. So 4.1, we are asked to write down the length of AB. So how can we find the length of AB with the information given? So we are given that A is equals to minus 2 and 0, right? So this minus 2 is the horizontal distance, which is the x value, right? So meaning from this point of origin up to this point here, it's 2 units, right? Now we want the distance from the origin to this point of A, so that when we combine both of them, they give us the length of AB, right? So for us to find that, we need to find the coordinates of B, of which we're not given, but we know that B touches the straight line and the parabola. So the straight line, the equation is equals to x minus 6, and for B, the coordinates for B, we don't know x, but we know y is 0. So if we substitute 0 in this straight line, equals to x minus 6, and we transpose the 6 to the other side, x would be equals to 6. So it means now that the coordinates of B is 6 and 0. So the distance from here, from the origin to this point here, is 6 units, right? So the distance of AB will be equals to the 2 units plus the 6 units, giving us 8 units. So this is the length of AB. So now we're going to do 4.2. We are asked to find the coordinates of D, the turning point of F, right? So if we go back to this diagram here, and the equation of F, we are given the equation of F of x, which is this one here, and what we can tell is the x value of the turning point. This is the x value of the turning point. So the x value of the turning point is equals to 2, right? And we want to find the coordinates of D, right? So what we know is this, is that this is D and the coordinate is 2, and we don't know the coordinate of y, right? But we know that x is equals to 2, it's this line here, right? So for us to find the coordinate of y, we know that the straight line also passes through this point. So you can substitute from the straight line, which is y is equals to x minus 6, right? And we know the value of x of D is equals to 2. So let's find the value of y. So it's going to be equals to 2 minus 6. Y is equals to minus 4. So the coordinates for D would be 2 and minus 4. So these are the coordinates of D. So now 4.3, we are asked to show that the equation of F is equals to this expression here. So for us to show that, let's say we have f of x being equals to the a value into x minus x1, x minus x2, right? And our x-intercepts are what we're going to substitute here, right? How do we find the x-intercepts? So we know that the x-intercepts are the value of a and b. So a is minus 2 and 0, b is equals to, so we found b to be equals to 6 and 0 from the previous questions. And now we're going to substitute the x-intercepts where there's x1 and x2. So f of x equals to a into x minus 2, x minus 6, right? So f of x is equals to a into x plus 2, x minus 6, right? So having this equation of f of x equals to a into x plus 2, x minus 6. Let's substitute a point so that we can find this value of a. An equation is not complete until you find the value of a. So for us to find the value of a, we must substitute a point. Because this is a graph of f and we know the point of d now being equals 2 and minus 4. So we can simply substitute that. So where there's y, put minus 4 is equals to a into, where there's x, you're just going to put the value of 2. So it's 2 plus 2 into 2 minus 6. So this is minus 6. And then minus 4 is equals to a into 4. And 2 minus 6 is minus 4. So it's going to be minus 4 is equals to a into minus 16. Divide by minus 16 both sides. A value is equals to 1 over 4. So this is the a value. F of x is equals to a into x plus 2 x minus 6, of which our a value is 1 over 4, so it's going to be 1 over 4 into, finding the product here, you're going to get x squared minus 6x plus 2x minus 12, which is 1 over 4 into x squared minus 4x minus 12. Right, so now we're going to multiply the 1 over 4 inside every term that it finds, and then you're going to get x to the power of 2, x to the power of 2 over 4 minus 4x over 4 minus 12 over 4. So the solution would be the following. I'm just going to write it here. So now we're having this expression here, which is f of x. So the solution for this would be f of x is equals to x to the power of 2 over 4 minus x minus 3. So this is the solution of f of x. So now we're going to do 4.4. The question says that determine the value of k if E is the reflection of C with respect to the axis of symmetry, right? So now we want to identify the value of K. Remember that the coordinates of C were calculated as 0 and minus 3, right? So these are the coordinates of C. And we are told that they are a reflection of the axis of symmetry. So this is the axis of symmetry, and we know that the x value of the axis of symmetry is 2, right? So if these coordinates were reflected about the axis of symmetry to give this coordinate of E, it means now that where there's going to be a change of values, right? What do I mean by that is this value of x being equals to 0 here at E, it's no longer 0, right? So it was 0 from C, but it's going to be 4, right? 4 units. So the only change here is the x values, right? Because it's moving in a vertical form, right? So for the mere fact that it's moving in a vertical, so only the x values are changing. X was equals to 0 here, and now x is equals to 4 here. But the y values remain the same. So here, the y value was equals to minus 3. The y value will remain here. So the coordinate of E will be 4 and minus 3. So meaning that our k value is equals to minus 3. So that is how we find this k being equals to minus 3. Now, doing 4.5 says that determine the equation of the tangent to the curve at E if the tangent is parallel to G. So we're going to this diagram here. So let me first erase everything here. So now we are to write down the equation of the tangent, right? And we are told that the gradient of the tangent and that of line of G. So this is our graph of G here. So this one here is our graph of G. We are told that the gradient of G is parallel, right? So the gradient of G is parallel to the gradient of T, of tangent, meaning that parallel gradients are equal. So meaning that the gradient of G will be equal to the gradient of the tangent. So let's have a look at the gradient of G. So there it is here, it's equals to 1. So m of G is equals to 1. That means m of tangent is equals to 1, right? So now that we know the gradient of the tangent, so we know the equation is equals to mx plus c, where the gradient is equals to 1. So y of t is equals to x plus c, right? And we are told this statement here that the gradient, the tangent to the curve at E. So it means now that the tangent passes through point E. So chances are it might look something like this. Alright, so this would be the tangent. So this means now that we will use the coordinates of E to find this value of C, right? So these are the coordinates of E, so you're going to substitute. This is X value, this is Y value. So where there's Y, we're going to put minus 3 is equals to, where there's X, we're going to put 4 and then plus C. Transpose the 4 to the other side, we have minus 3 minus 4 is equals to C. Which would be minus 7 is equals to C. So this would be the C value. And the equation of the tangent would be y of t is equals to x minus 7. So this is the equation of the tangent. Okay, now 4.6, we are asked to find the values of x such that f of x minus g of x is less than 0. Right, so we can just transpose the g of x to the other side and we'll have f of x is less than g of x. So always remember, when you talk of f of x, we're talking of the value of y. When you talk of g of x, we're talking of the value of y. So you're looking at the behavior of the value of y in the graph of f of x and the graph of g of x. So what we're going to look here is we're going to look at a point where, or points rather, where the graph of f is less than the graph of g, and we want the values of x when that happens. So where in so remember that this is your graph of f, this is your graph of g. So we want a point where f of x is less than g of x. Where does that happen? So this is f of x. Remember, this is f of x. It's below g of x at this point. It's below. And this is g of x. It's above, right? So this is the point where that happens, where this is f of x and this is our g of x. G of x is above. So these are the points. So points are here D and B, where f of x is less than the g of x. So you need to write the x values of that situation. So x here is equals to 2, and here x is equals to 6, right? So when x lies between, so you can either use lies between, or you can say when x is greater than 2 or x is less than 6, you can just simply use these solutions. Or someone can just say when x lies between 2 and 6. So someone can simply write this here, will also be correct. 4.7, determine the coordinates of the turning point of h. If h of x is equals to f of x plus 2 plus 1. Okay, cool. So we are asked to find the turning points, right? Remember, this is f of x. We identified the equation previously. So f of x is equals to x squared over 4 minus x minus 3, right? And also remember that we already know the turning points of the graph. We identified the turning points in the previous questions. How did you identify them? We know the turning point of D, right? We know the coordinates of D to be what? To be 2 and minus 4. So that is the turning point. So we can simply write our f of x in this format. We know the value of it's ax plus minus p squared plus q, and we know our value of a, it's 1 over 4, and then as I said, d is 2 and minus 4, right? So our x value is going to be minus 2 here squared, and then minus 4, right? So this is our f of x, and we are told that h of x is equals to f of x plus 2. So where there's x, we're going to add 2. So what this means is you have f of x is equals to 1 over 4 into, so instead of writing this x, you're going to write x plus 2. It's going to be x plus 2, and then you write this minus 2 here, so it's minus 2 all squared, and then you're going to write plus 1, right? So it's minus 4 plus 1. So that is going to be your h of x. So let me remove this here since I substituted the values. So it's going to be your h of x, the equation of the h of x. And remember, we want to find the coordinates of the turning point. So it's going to be h of x is equals to 1 over 4 into, so the 2 and the minus 2 will cancel out, so it's going to be x squared, and minus 4 plus 1 is going to be minus 3. So we can tell from this equation the turning point of it. The x value of the turning point is equal to 0 because here it's only x, and the y value, or the q rather, is equals to minus 3. So the turning point of the graph of h of x is going to be 0 and minus 3.